So here we have another wedge problem, block and wedge problem. In this question we need to find out the acceleration of the two blocks and the tension in the string when the masses of both the objects are 1 meter and the sides as given. Now in this question, intuitively we find we have to apply two Newton law equations. Now we have to choose two directions in which to apply Newton's law. These two directions should always be chosen wisely. Now in this question, the two directions which we should choose are this direction and this direction. It is always better to apply the equation along the incline and along the length of the string. So when we apply the equation on the left side, tension is acting here. Let this be theta. The force acting on this side is 1 into g into sine theta. This is 1 into g into cos theta. The normal reaction acts like this. Let the acceleration of this block be a on this side. For the other block, it experiences 1g cos theta on this side. It is actually 1g sine of this angle, but sine of this angle is equal to cos of this angle. 1g cos theta, 1g sine theta, normal reaction again, and tension. Now the acceleration of this block in this direction will also be a. This can be found out by either by applying string constraint, or you can see it directly also. Because if this moves by dx distance here, this block will move by dx distance upwards, because this is only one string and its length cannot change. So by applying equation on this block, we get g cos theta minus t equals 1 into a. By applying equation on this block along the incline, we get t minus g sin theta equals 1 into a. When we add these two equations, we get g of cos theta minus sin theta becomes equal to 2a. If our acceleration is equal to g by 2 into cos theta minus sin theta. So the acceleration is equal to g by 2 into 3 by 5 minus 4 by 5, because cos theta is equal to 3 upon 5. This gives us acceleration is equal to minus g upon 10 meters per second square. That is equal to minus 1 meters per second square. So negative sign tells us that the acceleration is actually in a direction opposite to that in which we had assumed it to be. Therefore, we had assumed acceleration to be in this direction a. It comes out to be minus 1. That means actually this block is going down with acceleration 1 meters per second square, and this block is going upwards with acceleration 1 meters per second square. We already know the acceleration of the object. Now we need to find out the tension. For finding out the tension, we feed in the values here. T minus g sin theta is equal to minus 1. We get t minus 10 into sin theta is 4 by 5 is equal to minus 1. Therefore, we get the tension as 7 newtons. So final answer is the tension in the string is 7 newtons, whereas the acceleration of the two blocks is 1 meters per second square. This block is moving downwards, this block is moving upwards.